Hello, Jeff Will here, and I have a couple of students in my office with a question, so I thought I'd start with another example. Let's say that we have some simple C code, and we are going to have a complicated array assignment. Let's get set up and see what the givens are. In our C code, somehow, we instantiate A, B, and C, so we have the A, B, and C variables. Then we do something with them. We also declare these arrays, A and B, of different sizes. So when that happens in the C program, the compiler has to make these decisions, but I'm giving them to you as parameters for the problem. Let's say that A is associated with R1, B is associated with R2, C is associated with R3. Then the address of the 0th element of B, an address, is stored in R20. The address of the base of A, or where where A of 0 is located in memory, is the address stored in 30. Then we got some trash registers. All right, are you ready for this? Let's say that A is pretty long, so I'm going to say A of 1400 is equal to B of A plus B minus C. Heavens to Betsy. Okay, well, what I'm going to need to do is find 4 times this value, add it to the base of B, then retrieve the word. A couple of different ways we can do this, but I think the most simple way to do it is to do that internal sum. We're going to take A plus B minus C, and we're going to have the index. We're going to multiply that index times 4, then we're going to go grab the word. Then, after we have that word, we don't have to do anything with it. We don't have to add anything to it. We just need to retrieve that word, then store it directly into A of 1400. Now that's the number of words, 1400 words. So we're going to eventually need to multiply this by 4, but let's handle that at the end. Okay, let's start with a temporary register. We'll start with 10. We're going to add into 10 A and B. So that's going to be 1 and 2. Then we're going to subtract, and let's go ahead and put it in 11, that sum A plus B, which is in 10, and we're going to subtract off C, which is register 3. Now, we run screaming, and we flail around, and we thrash out at other people, and we start climbing trees, and we dress in horsehair and eat locusts and wild honeys, or we say, wait a minute, this isn't so bad. All right, so why don't we take another register? What we ultimately need is value stored in our 11 times 4, and so that actually isn't that bad. Okay, so this is going to be 2 times the bracketed value stored in 12. We're going to do it one more time to get 4 times that. 12, 12, and 12. And now we have 4 times this indexed number within B, and that is the number of bytes. A plus B minus C is the number of words. 4 times A plus B minus C is the number of bytes, and we are dealing with bytes. Next, we need to find the absolute address of B of A plus B minus C. That's the lowercase b, not the capital B. So, add, and we've got plenty of temporary registers. We're going to take 12, which was that 4 times the value. Now we're going to take the base of B, which is 20. And now we've got the absolute address. What do we have to do? Go get it from memory. So now we can finally do our load word, but we've got the absolute address in here. So we're going to have a 0, and this is our address. Where are we going to put it? So this is the destination. We've got one more temp register left. Yes, I could do this with many less temporary registers, but since I've got so many of them, I'm going to be using them. So now the word stored at this address needs to be put into A. But there's no variables in A, there's just 1400. So we're going to need to take 1400 times 4, that's going to give us 0, 0, 16, carry the 1, 5600. And we can directly do the store word, and we want to store what's contained in our 14, and then our constant offset, we don't have to do any monkeying around. And what's the base of A? 30. Will out.